Okay, so this is going to be for the NPN transistor. We're going to use a 2N4401. We're going to set it up standard with a voltage divider right here. There's our voltage divider. Our pot is connected between 12 volts and ground. Okay, here's our wiper. Our wiper can go up or down. If it goes up, it increases the voltage to the base, and if it goes down, it decreases it. If we go all the way to 0 volts, then the transistor will be in cutoff. If we go all the way to 12 volts, then it will be in saturation. But we don't have to go all the way up to get it to saturation. So what we did was we put our meters across CE. So we were looking for voltage CE. And that was part of the table right over here. We started with the variable pot. Put our voltmeter across CE, and as we turned our voltmeter up, this became more closed until it was completely closed. There was just a slight bit of voltage across here. For most of you, it turned out to be about 0.09 volts. So you would have filled that into the table right here. We would have filled it in right here, 0.09 volts. Okay, great, we've got that. How about all across RB? Well, across RB, what we did was we placed the meter here, and we just checked. So what was the voltage across RB, guys?
0.07.
Across RB? Should have been, across RB should have been a larger voltage. Casey, I know you got a large one.
What do you mean afterwards?
11.31. 11.35, okay? Okay, that's a drop across RB, not on the base. The base is going to show the forward voltage is going to be 0.07 or somewhere around there. Want to know what was the drop across RB? It was 11.3, right? Or somewhere in there, right? So if it was 11.3, that means that it was forward biased 0.7. So now we've got 12 volts, so we account for the power supply when we add them together. So then we looked at this and we said, what is the resistance here? We're looking for ohms. Okay? So we had to shut the power supply off. Boom, shut it off, because you can't measure resistance in a circuit with power to it. A couple of you tried, and what happened to your meter? Kind of went crazy, didn't it? Kept flicking on and off and doing strange things. Okay? So what we did was we shut off the power, so we had 0 volts to the system. Then we removed right here the resistor, and we just placed it. We just parked it somewhere so we could do a resistance test. Then we took our meter and we checked from here to, okay, where did we check? If we checked here, we just end up with this resistance, right? We need this resistance also. So if we took our meter and we put it right there, now we have this resistance, RB, plus this resistance, which would be R pot. Now what about this resistance down here? It doesn't matter. We were only trying to get the resistance required to get it to saturation, right? This actually looks like 2 fixed resistors when you move the wiper, doesn't it? So really, I could just say, okay, I'm just looking at this part of the resistor in the pot and this resistance. I add those two together, plus, right there. And when I was done, I had my optimum resistance. What did you guys get? About 20 to 23K, right? 20 to 27. Who had less than 23? 24. Okay, so we had about 23 to 27K for our optimum resistance. Why was it a little different? Because all the transistors are slightly different, okay? So each one of you got a little bit different voltage. And you filled that in. Then what I did was I gave you one that was as close as we could get. Most of you got a 22K, right? So we put a 22K in there. Oop, that's not where I want to do it. Right here. So we put in a 22K and it was fixed. Then we did the same measurements again, just to make sure that we had got the right resistor, right? Okay, and we found that it was the right resistor because we filled in our table, didn't we? Okay, so everybody got all those voltages.
Mine got .07 in BCE.
Okay, so it was a little bit different when you put the fixed in, but it was still in saturation. That's all you're looking for, okay? So what do we do now? Well, what we did was we figured out the minimum IB, current flow, required to turn this transistor on. That's what we did right there. We turned it on all the way, saturated it. The minimum IB. Used a resistor that would give us the minimum current through the base. Okay? That gives us the maximum amplification. We're using it as a switch, but it's turning all the way on and all the way off. And we want it to be all the way on or off when we're running our motors, right? Reverse forward. So now we know that if we use 22K ohm resistors on the bases in our H-bridges that we just built, instead of the 330 ohm, our circuit will draw the least amount of current. It will be optimum, okay?